Next problem. Find the pair of common tangents from 0, 0 to the circle x square plus y square plus 10x plus 10y plus 20 equal to 0. Solution. Right? Given circle is x square plus y square plus 10x plus 10y plus 20 equal to 0. That is equation number 1. We know that the equation of pair of common tangents from x1, y1 to the circle x square plus y square plus 2gx plus 2fy plus c equal to 0 is x1 square plus y1 square plus 2gx1 plus 2fy1 plus c into x square plus y square plus 2gx plus 2fy plus c, which is equal to xx1 plus yy1 plus g of x plus x1 plus f of y plus y1, that is g into x plus x1 plus f into y plus y1 plus c, this whole square. Right? Here x1 y1 equal to 0 comma 0. Right? So 1 implies 2g is equal to 10, g is equal to 5, 2f equal to 10, f equal to 5, c is equal to 20. Substituting in that formula, above formula, you will get the required equation of pair of tangents. Right? So 0, 0 plus 10 into 0 plus 10 into 0 plus 20 into x square plus y square plus 10x plus 10y plus 20 equal to x into 0 plus y into 0 plus 5 into x plus 0 plus 5 into y plus 0 plus 20 the whole square. So you will get 20 into x square plus y square plus 10x plus 10y plus 20, which is equal to 5x plus 5y plus 20 the whole square. So left hand side as it is, and the right hand side you can write 5x plus 5y plus 20 can be written as 5 into 4 the whole square. Right? So left hand side as it is, that is equal to right hand side you are taking 5 outside, so 5 outside means 5 square, that is 25 into x plus y, the x plus y plus 4 the whole square. So that is 25 and 20 we are getting cancel, so they are having 5 in common, so 4 into 5 20, so 4x is left hand side. Right? 4 into x square plus y square plus 10x plus 10y equal to 20, 5 into 5 25, so that is equal to 5 into, using a plus b plus c the whole square formula, a square plus b square plus c square plus 2ab plus 2bc plus 2ca, we are using that formula. So 5 into x square plus y square plus 16 plus 8x plus 8y plus 2xy. So 5 into x square plus y square plus 16 plus 8x plus 8y plus 2xy, we are taking left hand side to the right hand side, minus 4 into x square plus y square plus 10x plus 10y plus 20 equal to 0. So now we are simplifying, multiply by 5, right, in the first term. Right? 5x square 5y square, so plus 80 plus 40x plus 40y plus 10xy, then multiply by minus 4 the second term. Right? Minus 4x square minus 4y square minus 40x minus 40y minus 80 equal to 0. So grouping x square term, 5x square minus 4x square x square, right, 5y square minus 4y square y square, then 80 minus 80 get cancel, 40x minus 40x get cancel, 40y minus 40y get cancel, then remaining you are having plus 10xy equal to 0, which is the required equation of the pair of tangents. Next problem, from a point on the circle x square plus y square plus 2gx plus 2fy plus c equal to 0 to tangents drawn to the circle x square plus y square plus 2gx plus 2fy plus c sin square alpha plus g square plus f square cos square alpha equal to 0, where alpha lies between 0 to 90, that is pi by 2. Prove that the angle between them is 2 alpha. Right? So we are going to prove the angle between the pair of tangents which is equal to 2 alpha. Right? So given circles are x square plus y square plus 2gx plus 2fy plus c equal to 0, that is equation number 1. The second circle x square plus y square plus 2gx plus 2fy plus c sin square alpha plus g square plus f square cos square alpha equal to 0, that is equation number 2. We know that the angle theta between the tangents from the point x1 y1 to the circle, right, common tangent from the point to the circle is given by tan theta by 2 is equal to r by root of x1 square plus y1 square plus 2gx1 plus 2fy1 plus c. right, where r is the radius of the given circle. Let p x1 y1 be a point on 1. From that, right, from a point on the circle, so we are taking that point p x1 y1 on 1. From that point there are two tangents drawn to circle 2, right. Since the angle between the tangents is given by tan theta by 2 is equal to r by, so using the formula x1 square plus y1 square plus 2g x1 plus 2f y1 plus, instead of constant term you are having two terms, right. So r by x1 square plus y1 square plus 2g x1 plus 2f y1 plus c is from 2, so we are having constant term c sin square alpha plus g square plus f square cos square alpha, right. So that is equation number 3. 2 implies the radius of r, right. So from the second equation we are going to find the radius of the second circle, which is equal to g square plus f square minus c, right, that is equal to root of, g is g, f is f for the second circle. C is minus c sin square alpha plus g square f square cos square alpha. So that is equal to g square f square minus c sin square alpha minus multiply by minus g square plus f square cos square alpha. That implies r is equal to, so first term and the last term inside the square root, g square f square is common, take it outside, g square plus f square 1 minus cos square alpha minus c sin square alpha. So that is equal to root of g square plus f square 1 minus sin square alpha is, 1 minus cos square alpha is sin square alpha, right, minus c sin square alpha. Taking sin square alpha common, so take it outside in the square root, inside the square root, right, root of g square plus f square minus c into sin square alpha. So r, which is equal to, take that sin square alpha outside from the square root, it will become sin alpha root of g square plus f square minus c. That is equation number 4. Since p x1 y1 lie on 1, p x1 y1 satisfy equation 1. Put x is equal to x1 and y is equal to y1 in 1. So we will get x1 square plus y1 square plus 2g x1 plus 2f y1 plus c equal to 0. Therefore minus c is equal to x1 square plus y1 square plus 2g x1 plus 2f y1, right. So we are taking that c plus c to the right hand side, it will become minus c, right. That is equation number 5. So using 4 and 5 in 3, tan theta by 2 is equal to minus r by x1 square plus y1 square plus 2g x1 plus 2f y1 plus c sin square alpha plus g square plus f square cos square alpha, that is equal to r is sin alpha root of g square plus f square minus c, right, divided by x1 square plus y1 square plus 2g x1 plus 2f y1 from 5, that is minus c plus c sin square alpha plus g square plus f square cos square alpha, that is equal to sin alpha into root of g square plus f square minus c whole divided by root of minus c, right. We are taking minus c outside from the first two term inside the square root, right, minus c into 1 minus sin square alpha plus g square plus f square cos square alpha. So that is equal to sin alpha root of g square plus f square minus c divided by minus c, 1 minus sin square alpha is cos square alpha, so minus c cos square alpha plus g square plus f square cos square alpha, that is equal to sin alpha into root of g square plus f square minus c divided by root of cos square alpha. So from these two terms cos square alpha is common, take it outside, cos square alpha into g square plus f square minus c, right. So sin alpha into root of g square plus f square minus c divided by, take the cos square alpha outside from the square root, so you will get cos alpha, right. So cos alpha root of g square plus f square minus c. So g square minus f square plus c in the numerator, root of g square plus f square minus c in the denominator get cancelled, so you will get tan alpha. So tan theta by 2 is equal to tan alpha, so that theta by 2 is equal to alpha, so theta is equal to 2 alpha, which is to be proved. Thanks.